All right, class, in this lesson, we are going to learn to prove the Pythagorean identity and then use it to find trig ratios in right triangles. So let's go ahead and get started. All right, so what we're going to do is prove that for every right triangle, sine squared of theta plus cosine squared theta is equal to 1. Okay, now we're going to start with the Pythagorean theorem, which states a squared plus b squared is equal to c squared. Okay. What this means is the leg of a right triangle squared plus the other leg of a right triangle squared is equal to the hypotenuse squared. Now we're going to go ahead and manipulate this equation by dividing both sides by c squared. Okay, and when we do, we're going to go ahead and split this fraction up into two different parts. This gives us a squared over c squared plus b squared over c squared, and that is equal to 1. Okay, now let's go ahead and rewrite both of these fractions and simplify it. We'll make it look a little cleaner. We're going to write this as a over c quantity squared plus b over c quantity squared. That is equal to 1. Okay, now let's take a look at this triangle here and ask ourselves, relative to this angle theta, okay, what trig ratio gives us a over c? Okay, we're looking for a over c because we have a over c here. And if you recall from SOHCAHTOA, the trig ratio that has a over c is opposite over hypotenuse, which is sine. Okay, so we can say that the sine of theta, which replaces a over c, squared plus, what is b over c relative to theta? Well, b over c would be adjacent over hypotenuse, and that's equivalent to the cosine theta ratio. So this is cosine of theta squared, that is equal to 1. Okay, now in trigonometry, you can actually rewrite sine of theta squared as sine squared theta. And the same thing for cosine theta squared. That's the same as cosine squared theta. That is equal to 1. Okay, and so what we essentially have is the Pythagorean identity. And this identity is going to be the basis for our lesson today. Okay, so let's go ahead and take a look at the next example. Okay, here we are asked to solve for tangent of theta if we know what cosine of theta is, which is 3/5 here. Okay, so the first step here, okay, first major step is to use the Pythagorean identity to find sine of theta first. Okay, we need sine of theta because in order to solve for tangent of theta, we need both sine of theta and cosine of theta. So let's start with the Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1. Okay, so we're going to leave sine squared theta as is. Okay, but this time we know what cosine squared theta is because cosine of theta is 3/5, so that means this is going to be 3/5. Let me write this a little bit better. 3/5 squared is equal to 1. Okay, and further simplifying 3/5, this works out to 9/25. That is equal to 1. Now what we want to do is move the 9/25 over to this side of the equation, and we can do that by subtracting 9/25 from both sides. Okay, when we do, we now are left with sine squared theta, and these cancel out, so now we have 1 minus 9/25. Okay, so we want to combine these two. In order to do that, this number has to have a denominator 25. Okay, so what that means is we can rewrite 1 as 25 over 25, and now we can subtract 9/25. So now when we do, sine squared theta works out to be 16 over 25. And then we can take the square root of both sides. And when we do, we get sine of theta is equal to 4/5. Okay, 4/5. Okay, so now that we've finished step 1, we're going to go ahead and move on to step 2. Okay, and as I mentioned earlier, tangent of theta is equal to sine of theta over cosine of theta. Well, what is the sine of theta? Well, we just solved it. It's 4/5. Okay, so tangent of theta is equal to 4/5 divided by, and what is the cosine of theta? Well, that's given to us in the problem up here, which is 3/5. Okay, so let's go ahead and enter that in. Now we need to resolve this or simplify it, and the way to do that is to focus in on the denominator and figure out how to make this a 1. Well, we can do that by multiplying this by the reciprocal. Okay, so we're going to multiply this entire fraction by the reciprocal over the reciprocal. And we can do that because this value is just 1. So that way we don't change the value of all of this. And look at this. See how we have 3/5 and 5/3 here? These cancel each other out. Right? We have a 5 up here, 5 down here, so that cancels out. 3 up here, 3 down there, those cancel out. So now the entire denominator is equivalent to 1. And so now what we're left with is tangent of theta is equal to 4/5 times 5/3. And as you can see, the 5's cancel each other out, and now tangent of theta is equal to 4/3. Okay? So that is our answer for this problem. Now, let's move on to the next example, where now we're given tangent of theta. We have to find sine of theta. Okay? So what we're going to do in step 1 is use the Pythagorean identity and find cosine of theta. So let's go ahead and write that out. Sine squared theta plus cosine squared theta is equal to 1. Okay? Now we're going to manipulate this equation so that we can go ahead and use this tangent of theta. So we need some sort of sine over cosine. So the thing we're going to do with this equation is divide both sides by cosine squared theta. Okay, cosine squared theta. And then what we're going to do is separate this fraction here. This works out to sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta, and that is equal to 1 over cosine squared theta. Okay, we're not going to make any changes to the right side of the equation just yet. We're going to leave that toward the end. Okay, so if you take a look here, sine squared theta over cosine squared theta, that really is the same thing as sine of theta over cosine of theta, quantity squared. Okay, and then the next fraction, we have cosine of theta divided by cosine of theta, which is just 1, and that is going to equal 1 over cosine squared theta. Okay, now take a look. We have sine of theta over cosine theta. That is really the same thing as tangent of theta. Squared plus 1 is equal to 1 over cosine squared theta. Well, what is tangent of theta? It is 5/12. Okay, so now we could replace tangent of theta with 5 over 12 squared plus 1 is equal to 1 over cosine squared theta. Okay, this is a fairly long problem, so bear with me for a little bit longer. We're going to go ahead and multiply this out, the 5/12. Okay, and when that is squared, that works out to 25 over 144. Okay, we also want to add 1, right? We want to add 1 to this fraction, but we're going to rewrite the value of 1 in terms of 144 as a denominator. So that's going to equal 144 over 144. Okay, and that equals 1 over cosine squared theta. Now, as you can see, we can go ahead and combine these fractions. because they have the same denominator, and this works out to 169 over 144 is equal to 1 over cosine squared theta. All right, so now what we can do is square root both sides, and when we do, the value on the left side of the equation works out to 13 over 12, and on the right side of the equation that works out to 1 over cosine of theta. Okay, now remember, our objective is to find cosine of theta, but we have 1 over cosine of theta right here. But what we can do is flip our fraction around so that this becomes 12 over 13, and that is equal to cosine of theta over 1, which is equal to cosine of theta. Okay, so now we know cosine of theta is 12 over 13. So now that we know that, we can find sine of theta. Well, how do we do that? Let's go ahead and set the equation. Tangent of theta is equal to sine of theta over cosine of theta. We can now multiply both sides of the equation by cosine of theta. And when we do, these cosine of theta cancel out, and now sine of theta is equal to cosine of theta times tangent of theta. Okay, now this looks a little bit confusing, but we can go ahead and replace cosine of theta with what we just solved here, right? Cosine of theta is 12 over 13, so cosine of theta can be replaced by 12 over 13. And tangent of theta is what value? Well, it's given to us at the beginning of the problem. It is 5/12. So we can multiply this by 5 over 12, and this is going to give us sine of theta. Okay, we have a 12 in the bottom and a 12 at the top, so those cancel out. And what we're left with is 5/13, and that is sine of theta. Okay, and that is our answer for this problem. Okay, hopefully that made sense to you. I know I went through this fairly quickly, but if any of this was confusing, please go back to the beginning of the recording and listen to it again. Thank you.